So, we're going to review balancing equations as we talk about the different types of reactions. And that's what you're going to be observing in lab tomorrow. You're going to be doing experiments to determine and observe the different types of chemical reactions. We classify reactions by what type they are. In other words, what's taking place. All right. Why don't you take a second and tackle this one as a review problem. Iron 3 chloride reacts with calcium hydroxide to produce iron 3 hydroxide and calcium chloride. Write a balanced chemical reaction. If I give you a formula, you should be able to give me the name. If I give you a name, you should be able to convert it to a formula. So this is a review not only of yesterday, it's also a review of last week. So get used to seeing formulas in words instead of formulas. Take the words, convert them into a formula, and then write an equation, and balance it.
Here,
What?
we need our periodic table.
You can use your periodic table. Here's a hint. If you can't take a name and convert it into a formula, you need to practice writing formulas. Because that's a skill we learned last week. And there are practice problems on Angel on formula writing. 20 seconds. This is a review of last week, and it's a review of yesterday. Because from this point on, I am expecting you to be able to write a formula when I give you the name. Just like learning another language. If you forget all the vocab you learned on day one, you're not ever going to become fluent, right? If you forget how to write formulas, we learned that last week, you're not going to be able to make it much further past week 5. So formula writing is a challenge for you. Make sure you attempt those practice problems on Angel. And also there are a ton of them in your book. You can always email me if you want more as well.
Yeah, this particular one for the chloride. On our sheet we have chlorate and chloride.
This is chloride. It's not a polyatomic ion. What does the IDE tell you?
That is
Nope. The IDE ending refers to the element chlorine losing and gaining an electron becoming chloride. Remember, the IDE ending refers to the periodic table. Iron 3. How do we represent that ion? What do we write?
Fe.
Fe with what charge? 3 plus or plus 3. Right. And chloride, what's the symbol for that?
Cl.
Minus 1. So when I write the formula for iron 3 chloride, how do I know what to do? We use the crisscross method, right? I've got 3 of them, superscript, 1 of them in the superscript. That gives me FeCl3. Okay, calcium hydroxide. What's the calcium ion? How do I represent it?
Ca. +2.
Plus 2. And what's the hydroxide ion?
OH minus.
And how should I do that? With parentheses around it, right? Because what do I need to do to make this formula correct? The 2, does it go inside the parentheses or outside the parentheses?
Outside.
It goes outside the parentheses, right? And this becomes a 1. So this becomes Ca parentheses OH 2. If you wrote this on your paper, you probably had a hard time balancing it because that's not the correct formula. Why does the 2 need to go outside the parentheses?
because you have multiply the 2 by options.
Because you've got 2 hydroxide ions, right? All right, so those are our reactants. And I tell you the products are iron 3 hydroxide. So Fe plus 3 and OH minus, what's the formula there?
Fe parentheses
Okay. And my other product is calcium chloride. So calcium plus Cl minus, so what's that? CaCl2. Right. If that act right there was difficult for you, you need to practice writing formulas. I'm not trying to be mean, I'm just trying to make sure you are well informed. That if writing formulas is a challenge for you, you need to overcome that challenge. So come see me, consult your book, do the practice problems on Angel. There are lots of ways that you can get caught up. All right, and our coefficients are 2, 3, 2, 3. You agree? 2, 3, 3. Questions on this one? Review of yesterday. Yesterday we wrote formulas. We wrote balancing equations. Alright. Like I said, I'm not trying to be mean, but I do want you to realize that formula writing is something you can't do at this point. You are behind. Okay, so if you can't write formulas, please come get help. I have chocolate in my office, tissues, we can cry and eat chocolate, it'll be fine. We'll have a little meltdown, it'll be great. Alright, try this one. Magnesium metal reacts with silver 2 nitrate to produce magnesium nitrate and silver metal. By the way, what's the formula for magnesium metal? I've got a sheet of magnesium. What's its formula?
Mg.
Mg. Right, so when you see metal, it just means it's Mg.
But
What's the formula for, no charge, just Mg, plain old Mg. What's the formula for silver metal? Ag, plain old Ag. If I hand you a bar of silver and say, here's a bar of silver, it's worth a lot of money. It's just plain old Ag.
why wouldn't you put the charge on?
Because in its elemental form, it's not an ion. It's only got a charge if it's an ion.
So that's metal oxide, it's not in the ion.
It's not an ion if it's metal. So write the formulas and balance the equation. Make a reactive product table. Just plain old Mg. Now, that's ammonium. That's not nitrate. Ammonium is an H4. This is nitrate. We need to balance it. Okay, great. It's not NO4, it's NO3. Nitrate is NO3. That was yesterday. We balanced equations yesterday. I don't know off the top of my head. Okay, let's go over this one. Magnesium metal, what's the formula for that? Anytime you see the word metal, you should just write it plain as is. So, magnesium metal is what?
Mg.
Mg, and that's a solid, plus
Ag.
Ag.
Parentheses.
NO.
NO to the third.
Parentheses.
Parentheses 2.
good. Make sure that those are subscripts. All right,
Arrow.
and we're producing what? What is magnesium nitrate's formula?
Mg.
Mg. Parentheses. NO.
NO3. parentheses plus AG plus AG.
AG.
Okay, so let's make our reactant product table. Mg, Ag, NO, Mg, Ag, NO, 1, 1, 2, 6, 1, 6, 2, 1. Do I need any coefficients?
No.
Nope. This time we got lucky. It's already balanced. So no coefficients needed there.
How do you know that the O has 6?
Because there are 3 and there's a 2 outside the parentheses, so I've got to distribute that 2 inside the parentheses. AG is only 1 because the parentheses are around the 19.
Yeah, I know. I don't, but why is the N only 2 and the O is 6?
Because there's 3 of them.
Okay, so is it
3
the O
times 2
N
is
has
6.
1?
Yeah.
Okay.
Okay, so there are several types of chemical reactions. We're going to learn all of these, not in November, in April. It's last semester's slide. So today we're going to learn about 5 of them, and then in April we'll learn the remaining 2. So in this class, this semester, you're going to be exposed to 7 different types of reactions, and the ones in red we're going to learn today. The remaining 2 we're going to get to in April. Synthesis, decomposition, combustion, single displacement, and double displacement. You're going to be seeing these 5 types of reactions tomorrow in lab. So make sure you understand what's going on, because the better it makes sense today, the easier it will be to recognize in lab tomorrow. Synthesis, decomposition, combustion, single and double displacement. We'll get to acid base and oxidation reduction.
We need to go write it down, but it's not where to focus on right now.
If you want to. Tomorrow in lab, you will see all 5 of these ones in red. Alright, let's get to it. First one. Oh, by the way, these are all summarized on page 172. So you might want to make a reference to yourself to page 172. That's a handy little table. That might come in handy tomorrow, and it might come in handy when you're doing your homework too. Alright, first one we're going to talk about is decomposition. So when something decomposes, it's usually a yucky association, right? Something decomposing, it's what? What's happening to it? Breaking down, right. So in a decomposition reaction, one substance breaks down into multiple substances. All right, so if you've only got one reactant and a whole bunch of products, you know it's decomposition. So for instance, calcium carbonate decomposing into calcium oxide and carbon dioxide gas. Potassium chlorate breaking down into potassium chloride and oxygen gas. Sodium nitride breaking down into sodium metal and nitrogen gas. You've got one reactant breaking down into a whole bunch of products, and there can be more than 2. You can have 3 products or 4 products. Just depends on what you're starting with. The hallmark of a decomposition reaction is if you've only got one reactant and a whole bunch of products. It must be decomposition. So we use the generic AB breaking down into A plus B. One substance breaking down into 2 or more products. So if I gave you a reaction like one of those 3 on the bottom and said, what kind of reaction is this, you would know that they're decomposition because what do they have in common? They all only have one reactant, right? And multiple products. So that's one of the key indicators that you can look for. Does everyone feel good about this one? Think you'd be able to spot it if I handed you a reaction and said, what is it? One reactant breaking down into multiple products. All right, let's go the other direction. Synthesis, or combination, same thing, is the reverse of decomposition. So decomposition and synthesis are opposites. If you've got multiple things coming together and you're only forming one product, it's combination or synthesis. You can name it whichever you prefer. If you call it combination, I'll accept that. And if you call it synthesis, I'll accept that. You've got options. It's good in life to have options. So the opposite of a decomposition is a synthesis. And the key hallmark of a synthesis reaction is how many products are you forming? Just one. So multiple things coming together to make one product. It is the complete opposite of decomposition. So if you look at these examples down here, we're forming magnesium oxide, we're forming ammonia, and we're forming bromobutane.
Four on that side.
Nope. It's a displacement. You don't need to worry about it, really. If you take organic chemistry, I'll show you where those two H's went. Alrighty, so does everybody understand the difference between combination and decomposition? They are opposite each other. Okay, so here are two ones for you to try. Hydrogen peroxide, H2O2, decomposes into water and oxygen gas. Let me give you a hint. What's the formula for oxygen gas? The gas that we are breathing that is essential to our life. O or O2, right. Why is it O2? As a gas, oxygen is what? It starts with a D. Diatomic, right. Remember the elements makes a 7. As a gas, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen, as gases, are all diatomic. So watch that formula there. And then also write and balance an equation for the second one. The surface of aluminum metal reacts with oxygen gas to form aluminum oxide. Imagine the word gas right there. So here's another opportunity to practice formula writing. You can buy hydrogen peroxide in the store. What kind of bottle does it come in? Brown bottle. Anyone know why it's a brown bottle? It'll decompose faster in light. Yep. And that's the actual reaction that will take place. So if you've got a really old bottle of hydrogen peroxide, sitting under your sink, it's mostly water. It's been sitting there a long time. Because it will decompose. Make sure your equation is balanced.
This is aluminum hydroxide. So those are the right formulas, yep. Now you just need to balance it out. That's good. Oxygen gas. O2. As a gas, it's O2. The two that's down here where you had it. And this formula is not correct. Only if I ask for it. You can. It would work if you use a fraction. Take another 20 seconds. Alright, let's do the balancing equations table for the first one. What kind of reaction is that, by the way? This is a decomposition, and we know that because we've got one product, one reactant forming multiple products. Okay, so someone tell me what you did to balance this.
39.
2, 2, 1.
2, 2, 1. So how'd you get that?
I don't know, I just did.
So we want to make this 1 into an even number, right? Because if I turn this 1 into a 2, I can turn this 2 into a 4, right? So if I put a 2 in front of H2O, that makes that 4, that makes that 2. And now, to balance it, I put the 2 right here, that makes that 4, what's that 4? So 4 and 4, 4 and 4. Okay, let's do the next one. Aluminum metal, the formula for aluminum metal is Al, and that's a solid. And oxygen gas is what? O2 gas. And we're forming, okay, let's do a little sidebar here. Aluminum has what charge? +3. And oxygen has what charge? -2. So this is what? Al2O3, right. And that is a solid. So let's make our table. AlO, AlO. All right, 2, 3, 2, 1. What should we do?
4, 3, 2.
Okay. So, how'd you get that?
You put a 2 in front of the product.
A 2 in front of the product, okay. So you're saying
2, 4, 6.
I'll turn both of my oxygens into 6, right? Because I can't turn a 3 into a 2, and I can't turn 2 into a 3. So let's just turn both into 6. So then that means you had to put a what right here?
3.
3. 6 here. And then the 4 to balance the aluminums. 4, 4, 6, 6. What kind of reaction is that one? Synthesis or combination. I would accept either one. Synthesis or combination. Whichever you prefer. All right. Here's the next one. It's called combustion. Oxygen is always a reactant in a combustion reaction. Oxygen is always a reactant. Now, you've got to watch carefully. If you're doing combustion of a hydrocarbon, and a hydrocarbon is a molecule composed only of carbon and hydrogen, all right, C to the X, H to the Y, where X and Y are just whatever those subscripts are. If you're combusting a hydrocarbon, your products are always going to be CO2 and H2O. If you're combusting a metal, though, you're going to get a metal oxide. Because think about it. Can I produce CO2 and H2O if C and H are not reactants? No, it's not possible. So if it's a hydrocarbon, in other words, if it's a molecule composed only of carbon and hydrogen, like CH4 and C3H8, both of those are hydrocarbons. So when those react with oxygen, I'm going to get CO2 and H2O. And both of those products are gases, by the way. Those are always gases. That one's easy. But if it's a metal being combusted, you're going to get an oxide of that metal. You can't get CO2 and H2O if C and H are not reactants. So just look at what's being combusted to figure out what your products are going to be. If it's a hydrocarbon, you'll get CO2 and H2O. If it's a metal, you'll figure out what the oxide of that metal is. And then balance it, of course. We have to obey the law of conservation of mass. So the hallmark of a combustion reaction is you're always having what substance as a reactant? Oxygen in what state?
Gas.
Oxygen gas. We know it's oxygen gas because it's O2, right? We're breathing O2 right now. If we were not, we would not be having this discussion. combustion. This one right here could also be classified as something else. What could we also classify that one as? Synthesis or combination. Yeah, so that one's one where you could call it combustion, or you could call it combination / synthesis. I'll take either answer there. Can you call these combination though?
No.
No, because there's more than one product. Does everybody see the difference between combustion of a hydrocarbon versus combustion of a metal? All right, there's combustion. So here's what I want you to do. Write the balanced equation for the combustion of propane. Propane's formula is C3H8. And it is a gas. Most of you probably knew that though. Propane tanks. So based on this information, you should know what your reactants and your products are. Because I'm telling you that it is combustion. Because you're going to balance it. Knowing that it's a combustion, what kind of molecule is this? You should know what the products are based on that. For combustion, these two are always going to be gases. That's always going to be a gas. And most of these are 99 times out of 100 they're gases. So just get in the habit of including that information if you have it available. Stuck on your reactant product table, the best thing to do is just erase and start over. Usually if you get stuck and you're going in circles, you just erase, start fresh, it usually solves the problem.
And also, if you get stuck starting with carbon first, you could start with hydrogen first. You try it over. So, I've told you that this is combustion. What kind of molecule is C3H8? What do we call that?
Hydrocarbon.
That's a hydrocarbon. What's our other reactant? And how did we know that? Because I told you it was combustion, right? Combustion always involves oxygen gas. So, since this is a hydrocarbon, and it's combustion of a hydrocarbon, what are my two products going to be? Not C3,
CO2.
CO2, and what other substance? H2O, right. So, you can't see it, but if you've got a propane tank and you've got it lit, you're producing carbon dioxide and water, yes? All right, let's balance this. So let's list our elements. Let's see, 3, 8, 2, 1, 2 plus 1, 2. All right, let's balance the carbons. So let's put a 3 here, 3 times 2 is 6. And let's balance the hydrogens. Put 4 here, 8, 4. What do I need in front of oxygen? 5. 3, 3, 8, 8, 10, 10. I'm done. Questions on this one?
Where does that 3 go from the carbon?
Where does it come from?
Yeah, the C3, where does the 3 go? Because it's just not there anymore.
It's not there anymore, right? The carbon is converted into carbon dioxide. That's why I've got 3 in front of it to balance it. If it's a hydrocarbon, 100% of the time, you're going to get CO2 and H2O. Always. CO2, H2O. Doesn't matter what the subscript of carbon is here. Always CO2 and H2O. And then you're going to have to balance it to show that carbon didn't disappear. Okay. All right, the next one is called single displacement. And what happens here is one element replaces another element. One element in a compound replaces another one. So in other words, you're having an element reacting with a compound. How do I know that this is an element and not a compound? There's only one symbol, right? And how did I know that this was a compound? There are 2 symbols. So one element replaces another. So you ready to see the products? Check this out, I'm really proud of myself when I learned how to do this. All right, A and CB. It's like your boyfriend dumps you and starts dating someone else, okay? And it is always A getting kicked to the curb and C and B getting together. So here's an example of a single displacement reaction. Silver was with sulfate, but then copper came along and sulfate said, ooh, someone new. So copper broke up this happy couple, and now silver's all alone and copper's with sulfate. Why is it CuSO4 and not SO4Cu?
Cation just
We always
first.
write the cation first, right? Always write the cation first. That's why it's CB and not BC. Cation goes first.
So CO is the
And the other thing to watch out for is make sure that the formula here is chemically correct. Okay? Make sure that the formula you have here is correct.
That would be sulfate, that would be sulfide, because you don't have too many of them.
No, sulfate is SO4. In a compound, there are no charges. There are 0 charges. So you don't have any negatives or positives if you're writing a compound. All right, so the next one is called the double displacement. So you guys want to take a prediction about what happens here? All right, everybody switches, right? Both couples break up and they switch. So check it out, check it out, check it out. So A and B split up, and now C goes with B, and A goes with D. So both couples switch. So the difference between single displacement versus double displacement: single displacement, one element plus one compound, and they switch out, versus two compounds. That's the difference between single displacement and double displacement. Everybody switches in double displacement. Nobody ends up alone. Single displacement, one comes along and kicks another one out. And you said chemistry doesn't relate to the real world. You're watching Real Housewives of wherever. You can say, oh, it's a double displacement reaction that you got going on here. All right, so here's a real world example. Why is it KBr right here instead of KBr2 or K2Br2? Because you say, oh, there are 2 bromines here and 2 Ks right here, so why isn't it K2Br2? What's the charge on potassium? +1, and what's the charge on bromine? +1, -1. Right, that's why it's KBr and not K2Br2. So in other words, don't get married to these subscripts. You need to make your products make sense. Your products need to make chemical sense. If you're K2Br2, that's not correct. It's KBr, because potassium is +1, bromine is -1. So when you're figuring out your products, always make sure that they make sense. And also, what's the charge on copper over here? Copper's a transition metal, so it can be a lot of different things. So what's the copper charge here? +2, right. If it starts out as +2 over here, it's going to be +2 over here, which is why I've only got 1 copper. Because sulfate is what? SO4 with what charge? -2. So that's why there's only 1 copper and 1 sulfate. Because if copper's +2 here, it's going to be +2 over here as well. Okay, so watch your formulas. Watch them carefully. Careful formula right. Because if your formulas aren't correct, you're never in a million years going to get it to balance. I can tell you right now. If you're writing an equation and you're like, why won't this balance? Go back and double check to make sure that your formulas are correct. Does everyone understand double displacement? Okay, try this one. Magnesium metal reacts with copper 2 chloride. In A, all I want you to do is write the formulas of the reactants. In B, all I want you to do is write the formulas of the products. Then in C, I want you to tell me what kind of reaction it is. And then in part D, I want you to write a balanced equation. So by the time you get to part D, you will be good to go. And after we go over this one, we'll take a little mental break. Part A, all I'm wanting you to do is write formulas for the reactants. Part B, I'm wanting you to write formulas for the products, and then by the time you get to D, put it all together. Balance it. This formula's not correct. The right elements are there, it's just not the right ratio. Magnesium metal. This formula is not correct. So this is copper metal. So from copper. So yes, it's. No, just write a balanced equation. Oh, I didn't see it there. Yeah. Looks good. Okay, magnesium metal has what formula? It's just Mg, right. And how did I know it's plain Mg? Because it has the word what? Metal, right. And what's the formula for copper 2 chloride? CuCl2, good. Okay, what kind of products am I going to form? MgCl2 and Cu, good. So, what kind of reaction do I have then? Single displacement. Because I've got one element reacting with a compound. Magnesium came along and kicked out copper. Alrighty, and so, is this already balanced for me? Did I get lucky?
Yes.
Yes, this one's already balanced.
Does it matter on the reaction, like the copper comes first and magnesium chloride comes second?
No, if you wrote MgCl2 first and plus Cu, that's fine. It's like saying 2 times 3 or 3 times 2. Alright, let me pause the camera for a minute so we can take our brain break.
You can leave it, Francis. You don't have to. Yeah, that's correct. Wait, have it. No, because you balance it based on your formulas. So you balance it based on your final formula. We ready? What are our reactants? Formulas. Good. Now remember, if you're writing a formula, there are no charges. Your final answer of your formula should not have any charges. Why? An ionic compound is neutral. There are no charges. Yes?
Is it wrong if you put that SO4 first?
Nope, that's perfectly fine. What are your products that you're forming? CaSO4 and COCl2. What kind of reaction do we have going on here? Double displacement. And this one is also already balanced for us. When you've got two compounds reacting. Not always. Not always. Double check it every time to make sure that it does. Sometimes the double displacement will not already balance. You just need to double check. Alright. Do this one. Sodium bromide plus manganese 2 iodide. These are all elements that were on your list of ones to remember. sure you do the pre-lab tomorrow for the correct experiment. We are skipping number 5 and doing number 5 next week. Switching 5 and 6. That's correct. Based on what kind of reaction? So that means that sodium is going to become in bond with iodine. So write the formula that will result from sodium and iodine. And then these two is going to be combined with bromide. Now you don't need this 2 here. Do you know why? Because sodium is +1 and iodine is -1. So it's just NaI. I just need to make sure it's balanced. This formula is sweet and then BR2. Because manganese is +2. +2 over here, it's going to be +2 over there. It's looking like you guys are catching on to this really well, so pat yourself on the back. What are the reactants? What are the formulas? NABR and not MG, MN, and Ni2. I got that. That's a really common mistake. And what are our products? NaI and NNBR2. Good. What kind of reaction do we have here? Double displacement. And here we do need some coefficients. This one was not already balanced for us. So again, make sure that when you write your reaction, you double check it. Don't assume that it's already balanced for you. You double check. Make sure. Okay, here are some pictures. So we're looking at the little pictures. What's the first one with the CD going to C plus D? What kind is that? Decomposition, good. The next one? Synthesis or combination, whichever you prefer. What about the next one? Single displacement. And the last one? Double displacement, good. Alright, so reactions we learned today. Now, here's what we're going to do for the next few minutes. I'm going to turn off the camera. And I've got some problems for you to practice. You may work individually